Hi, this is QBA at Hudson Valley again. This is the first video on simple interest. And I will go from the PC to the .cam and some examples. So please, I hope you printed out your handout because we will follow closely, not exactly on your handout. I will first jump over to the PC, and you can find these PowerPoint presentations on Blackboard. Now, the first slides will discuss definitions: interest, focal point, principal, interest rate, and term. You can do those by yourself. However, I would like to emphasize one of the data points, which is focal point. So we'll jump over to the .cam where I can show you. QBA, the key element is to take money and value it all at the same time. For example, if today, this is today, and somebody wants to give me $100, and interest rate right now is about 5%. Should I take this $100 or should I take $106 in 1 year? Okay, what's better? There's two different times. I have to value this $100 in 1 year, and its value would be $105 because of the interest rate. So waiting the year to take the $106 is the best value. If it was more complicated numbers, you would not know what is the best value. So because we valued both numbers a year from now, that is the focal point. Okay. Jump back to my PowerPoints. Simple interest. Simple interest is either paying for borrowing money, or if you lend money or you give money to a bank, getting interest on that money. So let's look at some problems we have here. Number one, a simple interest loan for $800 at 7% is paid off in what year? What is the interest charged? I tell students the formula you're going to use for simple interest is right here. I equals PRT. Interest in dollars equals the principal times the rate times time. Now, two things. Rate, your interest rate is always in decimal form. And your time will always be in a year. So, if we have your rate and it's 7%, you will change it for the equation to 0.07. If you have an interest rate of 2.5%, that's 2.5%. For calculation purposes, it's 0.025. Okay. If you have an interest rate of, let's say, 0.5%, that would be 0.005 in your calculation. You would use that number. Say you were getting 110%. Okay? In your calculation, R would equal 1.10. That's R. Time is in years. So, if I had 2 years, T equals 2. Whoops. If I had 2 years, 6 months, T would be 2.5. If I had 18 months, T would equal 1.5, right? 18 months is a year and a half. If I had 3 months, t, you could put it as a fraction, 3/12. If I was given interest for 20 weeks, again, put it in years. T would be 20 divided by 52 weeks in a year. Okay? We will discuss in a couple of minutes when we go to days. Sometimes in days, if we have interest for 30 days, we might say 30/360. Or depending on the instructions, it might be 30/365. So you have to pay attention to the instructions. When we go to days, you will be using, here's one side of your formula sheet, the other side of your formula sheet gives the number of each day of the year. For example, today is September 10th. I would look at September, come out down to 10. September 10th is the 253rd day of the year. So if I put money in the bank today, 253, which is September 10th, and let's say I took it out on November 2nd. On November 2nd. November 2nd is 306 day. So on September 10th was 253. I take it out on November 2nd was 306. How many days of interest? Well, you just take 306 minus 253, 3, and we had 53 days of interest. We'll talk about this in a couple of minutes. Okay, I'm going to turn off the doc cam and go back to my PowerPoints. So here we have the interest. Principal equals 800, 0.07 is our rate. And for 1 year, we have $56 worth of interest. Okay, I'm going to let you go through question 2 and 2A by yourself. Sometimes in this formula, we're not just looking for interest, we might be looking for P or R for T. In this question, we're going to look for T. We're given 4,000, a rate of 0.07, and we generated $350. What is T? So we substitute in. And when we do our algebra, you have T equals 1.25. We don't talk like 1.25. You need to change that into years and months. So we take out 1 year. We have 0.25 years left. The next denomination down from years is months. So we multiply it by 12 months. And we have 3.25 times 12 months equals 3 months. So our answer should be written as 1 year and 3 months, or 15 months is acceptable. Let's say that problem, we got T equals 1.3 years. So we're going to take out that 1 year, but we have 0.3 years. So again, right here, 0.3 is multiplied the denomination, next denomination down is months, times 12 months. So we get 3.6. So that's 3 months. We put 3 months. But we have 0.6 of a month left. We take 0.6, and we're going to assume in this example that there's 30 days in a month. We know some months have 31, but in this case, we're going to assume 30 days. 0.6 times 30 days, we have 18 days. So 1.3 years equals 1 year, 3 months, and 18 days. In number 4, we are given a principal of $950. We're looking for the rate. Time is 9 months, so time would be 9 divided by 12, and the interest generated was $42.75. I did the algebra on the formula this time. We're looking for rate. So interest was $42.75 divided by 950 times 9 over 12, and we got 0.06. You change that to 6%. Now I want to caution you, especially on my PowerPoints, okay? The biggest problem students have is not knowing how to use their calculator, where to put the parentheses. This whole thing is in the denominator. So I want you to pause it and try to do this equation. Okay? I'm going to let you look at question 5 by yourself. You know what? Let's go to question 5. Question 5, $50,000, a rate of 12%, 30 years, and your monthly payment is $514.31. What is the interest for the first month? Well, there's some extra information here. You do not use the 30 years. So principal is $50,000, your rate is 0.12, and we want to know the interest I for 1 month, so 1 divided by 12. So we put principal 50,000 times the interest rate 0.12 times 1 divided by 12. We have $500 worth of interest. Our payment was $514.31. Our payment was $514.31. In that first payment, we paid $500 worth of interest. Therefore, on our principal of $50,000, we only paid $14.31 down. So here's the original principal of $50,000 minus the $14.31 we paid down on the principal. So after the first month, we still owe $49,985.69. Yes, almost seems unbelievable. I'm going to let you look at that problem. I'm going to let you read this for a second, a promissory note. Anybody can write a promissory note. If you need money to pay for Hudson Valley, you can write your grandmother a promissory note. Now, instead of just finding the interest at the end of the term, when I say at the end of the term, at the end of the loan, you not only owe the principal, but you owe the interest. So we are going to derive that future value formula. So S means maturity value or future value. And S could either be represented by S, MV, or FV. And it's the principal plus the interest. Well, instead of using I'm going to take that one formula I showed you a few minutes ago, and instead of using I'm going to substitute P times R times T into the formula right here. Then I'm going to factor out the P right here, and I'm left with P times the quantity 1 plus RT. This is the formula on the formula sheet to find future value S or maturity value S. So let's look at a problem with that, a difficult problem. A promissory note for $5,000, 8% simple interest due in 18 months. What is the maturity value of the note? Okay, we have $5,000 today. By the way, you'll notice I write these timelines. Those will help you. The $5,000 is due in 1 year. We also owe the interest. which will be $600. I know that. So we have to pay back $5,600 total. So in this formula, we are going to substitute $5,000 for P, 1 plus our interest rate of 0.08, and our time is 1.5 years or 1.5. So if we use this formula, we owe at the end of 1.5 years $5,600. I want you to pause a minute and do number 8. You have to do 3 different future value equations to solve that. And you'll notice on my PowerPoints that I write down the homework in red at the bottom of some of the slides. This is where I talk about days, and you'll use your day chart on the back of your formula sheet. Method 1 is for the numerator. Sometimes I will specify exact times. I showed you that. For example, April 14th is day 104. October 20th is day 293. If I subtract 293 from 104, I have exactly 189 days of interest. Sometimes the bank might not say exact time. They will say approximate time. When they say, or the equation says approximate time, you assume 30 days in a month. So let's look at the same example. April 14th, due on October 20th. We will calculate April 14th to October 14th. April 14th to October 14th is 6 months. So you will say 6 months times 30 days, or 180 days. Then from October 14th to October 20th is another 6 days. So 180 plus 6 days is 180 approximate days versus exact time was 189 days. So this is exact time, this is approximate time. Practice those. The denominator, we also have 2 options. If I specify in a problem ordinary interest, you will use 360 days for the denominator. If I specify exact interest, you will use 365 days for interest. Ordinary interest, 360. Exact interest, 365. I'm going to summarize these in this slide. The most common combination of those is Banker's Rule. 90% of your problems in this class and in the world will be Banker's Rule. That is exact time and ordinary interest. Exact time, you're counting the exact number of days from your calendar sheet, and you use 360 in the denominator. And that comes back when there were no calculators and no computers, that bankers liked a nice round number like 360, and they still use it to this day. I could say exact time and exact interest. Then you would use 365 as the denominator. I could say approximate time and ordinary interest. Or I could say approximate time and exact interest. Get familiar with all these 4 combinations, but as I said, exact time in the numerator and ordinary interest in the denominator, or 360, is the most common, and you will see on 90%. This concludes the first video on simple interest. Thank you.